All right, the unit circle. So just really fast, we're going to go review what we did yesterday really fast. I lost my black again. Brilliant. Okay. Okay. Ladies and gentlemen, I'm starting here at this angle of 0 radians. If I go all the way around, where does it end? 2 pi radians. I go halfway around, it ends at pi radians. If I take pi and divide it into 2 pieces, and I have pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. Very good. What are those ordered pairs on the quadrants? 1, 0. Oops. 0, 1.
Negative 1, 0, negative 1.
Good. Okay. All right. Now, if I take pi and split it. Yeah. Into 4 equal parts, then this would be 1 pi over 4. 2 pi's over 4.
3 pi.
4 pi over 4. 5 pi over 4. 6 pi over 4.
7 pi.
And 8 pi over 4, which is just 2 pi. Okay. So the nice thing about this stuff is that it all reduces, which I think is totally cool. So then the pi over 4 we found out was the same as a 45-degree angle, which makes this a 45, 45, 90 triangle. And we learned then that the leg length in the x direction and in the y direction would land us at what ordered pair? Radical 2 over 2 and radical 2 over 2. And if we move around the circle, the only thing that changes are the signs. So negative radical 2 over 2, positive radical 2 over 2. In quadrant 3, they are double negatives. Negative radical 2 over 2 and negative radical 2 over 2. And then in quadrant 4, positive negative. Positive radical 2 over 2, negative radical 2 over 2. This is what we did yesterday. And today we are doing pi over 3 and pi over 6 angles, which turns out all I really need to look at is pi over 6. So let's talk about pi over 6. All right, so again, starting with special right triangles, I'm starting with an equilateral triangle of side length 2. Ladies and gentlemen, what is an equilateral triangle? All 3 sides are congruent. 3 congruent sides. And if I have 3 congruent sides, what else must be true? 3 congruent angles. And so then each angle is 60 degrees. So 60, 60, and 60 degrees because that makes 180. Each side length here is a side length of 2, 2, 2, and 2. And what we're going to do is drop an altitude from this vertex up high here. So we drop altitudes all the time. And when I drop an altitude on an equilateral triangle, it turns out that it bisects the angle and therefore bisects its opposite side, which means this piece is 1 and 1 unit long. And then we bisected this 60-degree angle, which means this angle is 30 degrees. So we created just now a 30, 60, 90 triangle. I'm going to redraw that. This is my standing up tall 30, 60, 90 triangle. So we have a 60-degree angle. Up here is the 30-degree angle. My hypotenuse is 2, and this base is 1. So what do I want to do? I need to find my other side so that I can do some ratios. Pythagorean theorem. I'm going to call this side y because it's vertical, just like our vertical axis. So 1 squared plus y squared equals the hypotenuse squared. Always, always. 1 plus y squared equals 4. So y squared equals 3. And then to square root both sides, we get radical 3. Okay. All right. So that turns out that any 30, 60, 90 triangle has side lengths 1, radical 3, 2. What I need you to understand is that the short leg is 1. How do I know this is the short leg?
Because it's the opposite of 30.
Yes, because it's opposite the smallest angle. Right?
Yeah.
Right? Smallest angle, smallest side. Remember that? All right. And then our 90-degree angle is our biggest side, and so that 2 is the biggest value. 60 is right in the middle, and so is radical 3. So you can even check that radical 3 has a value of 1.73, so it's approximately 1.73 units in length between the 1 and the 2. Okay. So it's great now that we have the side lengths, we can answer questions about special right triangles that are of the class 30, 60, 90. So we want to know what's the sine ratio looking from the 60-degree angle. Radical 3 over 2. Very good. Opposite over hypotenuse. Radical 3 over 2. All right. What is the cosine ratio looking from the 30-degree angle?
Same thing. It's the same thing. Because the adjacent.
Yes, it is the same thing. So we're looking from the 30-degree angle. So then adjacent over hypotenuse is radical 3 over 2. Hey, that's kind of interesting, isn't it? That's a special thing. These are called cofunctions of complementary angles. Are congruent. We'll talk more about that. All right. All right, what about the tangent? Oh, whoa. What's pi over 3?
That's like
180 over 3, which is 60 degrees. So this says what's the tangent at a 60-degree angle. So looking from the 60-degree angle, tangent's going to be radical 3 over 1, which is just radical 3. Opposite over adjacent. All right, what's the sine of pi? Whoa, what's pi over 6?
180 over 6.
180 over 6, which is 30 degrees. So looking from the 30-degree angle, what's the sine ratio?
It's the opposite.
Opposite over
1 over square root of 3.
Nope.
Oh no, it's the sine. Never mind. Oh, 1. Take a second.
AJ, just.
Oh no, I was looking at you when she was putting it there.
So sine is opposite over hypotenuse, so 1 over 2. Okay? So when you are asked questions like these with 30s and 60s, you can just draw your 30, 60, 90 triangle if you want to. Or we can use the unit circle. Now, just like yesterday, I can take my standard 30, 60, 90 triangle with side lengths 1, radical 3, and 2, and I can scale it up, and I can scale it down. Is this triangle going to fit in my unit circle?
No.
Not without adjustment, because
It's big.
the hypotenuse is too long. Okay, it's too big. So here we go again.
That's beautiful.
Go ahead and draw yourself your little circle. So this is the rest of the unit circle. Pi over 6. Multiples of pi over 6. So go ahead and draw your x and y axis, the horizontal and vertical in there. I'm not going to spend as much time as we did yesterday, so we're going to kind of lightning speed through this. All right. My ladybug right now is sitting at 0 radians. If she travels all the way around the circle, how far does she travel?
2 pi.
2 pi radians, which is the ordered pair.
1, 0.
0. Guess what you're going to miss on your test?
Every point.
The ones and zeros.
You're gonna miss it on your test.
It's when I'm saying out loud.
We reverse it.
I'm sure that's everyone, to be honest.
Yep.
What?
All right, so my ladybug, then we go halfway around the circle, so she's traveled pi radians.
Where?
At -1, 0. All right, she travels here.
0, 1.
0, 1. And how far did she travel to get there?
Pi over 2.
Pi over 2. 1 pi over 2. 2 pi over 2. 3 pi's over 2. And that point is,
Zero negative.
thank you. Okay. 0, -1. I do this every time because it's those ones and zeros that we inadvertently reverse. Everybody does it. All right. Now we are looking at pi over 6 mainly. So I'm going to take pi and divide it into how many parts? 6 parts. So 3 and 3, yeah. So I already have 2. So I'm going to split those. So I have 1 section, 2 sections, 3 sections. Now, when you're doing this on your project, you're going to actually measure that, because what is pi over 6 equivalent to?
30 degrees.
30 degrees. 180 divided by 6 is 30 degrees. Okay? So this, you would take your protractor and you would actually measure out your 30 degrees. So line up that center. Holy mackerel. Dang, I am good. I didn't even plan that.
It's looking.
I mean, the one
Dang.
is a bit off, but everything else is like.
Wow.
Wow. Miss Mel, I think that you need a
Okay.
Nobel Peace Prize.
All right.
It's like, oh, you could put
So
dots
these,
on the
now,
box.
irritatingly, were a little bit off, so I'm going to check those. Okay. All right. All right. Anyway, so now if we divided this into 6 parts, what's this first one? How far does my ladybug travel?
Pi over 6.
Pi over 6. Very good. Now, whatever I do to the top, we want to do to the bottom. All right. And so let's go ahead and just count around our circle. This is pi over 6, or 30 degrees. 1 pi over 6. What's this?
2 pi over 6.
2 pi over 6, which reduces to
Oh,
pi over 3. Oh, look at that. That's totally cool. Pi over 3 is how many degrees? 60. 180 over 3 is 60. 1 pi over 6. 2 pi over 6. What's this? 3 pi over 6. What's this? 4
2
pi over 6, which reduces to
2 pi over 3.
For the project, are we going to be reducing them to the smallest one?
yes.
Okay. I just want to-
The question was, should we reduce on the project? Yes, though I'll accept either. I don't care, but you should always reduce. I just like the counting aspect of it. I think it's really nice. So 4 pi over 6, what's this one?
5%.
And then this is 6 pi over 6, and it reduces. Cool. And this is 7 pi over 6, and this becomes 8 pi over 6, which reduces. And then this becomes 9 pi over 6, which reduces. And then this becomes 10 pi over 6, which is 5 pi over 3. And the very last one, 11 pi over 6. And then if you go all the way around, it becomes 12 pi's over 6, which is 2 pi. Okay. So I really like that about counting pi's over 6. Everything reduces. It falls really nice. And you can see that this was the 30-degree angle, and then pi over 3 is that 60-degree angle. So I'm going to go ahead and use 2 colors here. So now our job then is to figure out these ordered pairs. So I'm drawing the angle right here. This is my angle in standard position where my initial side is on my positive x-axis, and here is my terminal side, and our angle is 30 degrees, or pi over 6 radians to travel there. Now again, our job is finding this ordered pair. What x and y values get me to this point on my circle? Well, just like before, we're going to drop an altitude. So I'm going to drop an altitude. When you drop the altitude, it is a rule that you must always go to the the x-axis. Sorry.
Can't go to the y, is that what you're
No,
saying?
exactly. So you never go to the y. You don't go horizontal. We always drop a vertical.
Because altitude is
Well, not necessarily, but for our purposes, it is. Okay? Okay? So, like, we're never going to drop a perpendicular this direction. Okay. Everything will be reversed. So, all right. Now, this, we just created what kind of triangle?
30, 60, 90.
A 30, 60, 90 triangle, right? So we have a 30 degree, a 90. This must be 60 degrees. So what are the side lengths on this little 30, 60, 90?
2, 1, and then 1. Radical.
Okay.
I'm
So,
speaking the right stuff, though.
sort of.
Yeah.
Okay. So the 1 is the short side. It's opposite the short angle. The 2 is opposite the right angle. Okay. Does this triangle fit in our little unit circle here?
No.
Ah, very good. We need to shrink it because right now this radius of 2 is too big. So I need to shrink it so that it's a radius of 1. So what do we need to divide by?
2.
Divide everything by 2. And so I get a side length for the hypotenuse of 1. This leg is radical 3 over 2. And this leg is 1/2. Ladies and gentlemen, if you can remember radical 3 over 2 and 1/2, then you have this memorized. Radical 3 over 2 is what I'm going to refer to as the long leg. All right? Why?
Pretty long.
It's longer than this guy, which we're going to call the short leg. Okay? The short leg is 1/2, or also known as 0.5. Radical 3 divided by 2 is 0.86. So you can see we have a short leg value and a longer leg value. Okay? You got that? It's rocket science, ladies and gentlemen. Okay? All right. Now, when you look at this triangle that I created, which is called a reference triangle, can you see this leg? Is it the long leg or the short leg?
That one's long.
That's the long leg.
This is adjacent to 30.
So this is the long leg. And so how long is this long leg?
It's
pretty long.
It's radical 3 over 2. And then this is the short leg. So how long is that? 1/2.
I mean, you,
Okay.
you weren't wrong. But you weren't
That's
right.
all. Okay. Hold it. All right. So that's great. So now we know that ordered pair. I need you to think in terms of short leg and long leg. So now we're going to go up here to this angle. What is this angle?
60 degrees.
Yes. What he said.
All right.
Just what he said.
So there's our big 60-degree angle right here, 60 degrees. And again, our job is to find this ordered pair, and to figure that out, I'm going to drop an altitude so that I can create what is lovingly called the reference triangle. Now, when you look at this triangle, can you see which leg is the long leg and which leg is the short leg? Can you see?
Yeah.
Okay. So to get to this point, I'm going to travel in the x direction. Is this the long leg or the short leg? Short leg is 1/2. And then in the vertical direction, I'm going to travel up. Is this the long or short leg? Long leg. Radical 3/2. Okay? Okay? You good so far?
Yes.
In my course.
Mine is so messy that
Hey,
I totally
go over here to 2π/3.
Well,
Now, I'm here at 2π/3. And again, our job is to figure out the ordered pair to get there.
so you dropped it.
So,
Drop the L now. Oh, it's the same. But
it's this,
negative.
yeah. Mhm.
The X is negative.
Yeah, so what I'm going to do is I want you to not have to drop the altitude, but you could if you wanted to. So you can imagine an altitude.
It's the same as that one on the other side at the 60 degree one.
It's
So you
negative.
just flip it.
It's just
negative.
flipped over. Uh-huh.
Yeah.
So again,
Hey, I'm doing that.
you can see we have
Big
the leg here. Is this the long or short? Short leg is 1/2 in the negative direction. And then this would be the long leg. You'll notice I made those guys purple.
Ow.
All right. So then I'm going to do my 5π/6 angle. And again, our job is to figure out this ordered pair.
It's the opposite of the first one.
Yeah. So again, you can imagine dropping an altitude, and it's very clear the long and the short leg. So my long leg is negative radical 3/2, and then we got to go up a short leg. So up 1/2. Okay. Now you're gonna go ahead and draw the rest of this. Now, I love they call these bow ties and butterflies. Do you see the bow tie?
Yeah. Blue.
The red bow tie?
Wait, oh,
Do you see the red bow tie?
Yeah.
Bow ties. The bow ties, always in the same order. They just change signs, right? So what's this order pair?
That's
both of them are
Negative, negative. And then over here, radical 3/2 and negative 1/2. Again, long leg in the x direction, short leg in the y direction. Going downward, it's negative. Bow ties, butterflies.
My bow tie's crooked.
Man.
Mine's not very
Maybe you should fix it up.
Don't talk to me about it.
I think I will.
Wait, what?
Yeah. You have no put that. You've been destroyed.
I got the same so great.
Okay. Aren't they great? Yeah.
Yes.
Okay. Now, do you see the butterfly? Yeah, you see the butterfly? Okay. So all the butterfly points are always 1/2 root 3 over 2. They just change sign. So this point is negative 1/2 negative root 3 over 2. Again, short leg and then the long leg down. So the 1/2 and the negative root 3 over 2. Over here, short leg, long leg. So 1/2 and negative root 3 over 2. So bow ties and butterflies is how I think about these things. Okay. Now, this is just the pi over 6 unit circle. So just in case you're curious, all the 45s nest in between. All right. So those fit in between the 30 and the 60 is our pi over 4. Right? Okay, so the same thing is true about yesterday. Yesterday we said, hey, what's the cosine of any angle?
Either X or Y.
The X.
X, that's one.
The sine ratio of any angle is
Y.
the y coordinate. How do you find the tangent?
Y over X.
Y over X.
Y over X. How do you find cotangent?
It's
Reciprocal
like
Reciprocal tangent. Good. And then if you want secant, you would just flip your x coordinate. And if you want cosecant, you'd flip your y coordinate.
Okay.
All right. Now that only works on the unit circle. So be careful.
Only works on what?
The unit circle. That's this. That's
Well, you'll see.
this.
Okay.
Yeah.
All right.
Oh, that's crazy.
Every time I think,
So we're continuing on. So it'd be 60 and then 120 and 180 and so it's just adding all the way around.
So
So you're counting all of those. This is 30, 60, 90, 120, 80, 10, and just keep adding 30.
no, I don't think I will treat it.
So that should be 2 pi. And that should be 0.
Oh.
All right, we want to find the exact value of each trigonometric function. Now, if you want, you can just look at the circle that you drew. Or that unit circle paper that I handed out to you. A lot of people were filling that out during notes. That was smart.
Oops.
All right, so 300 degrees. Where is 300 degrees?
It's in the third, or it's in the fourth one.
Fourth quadrant. I meant to go here. That's where I meant to go. So this is 270. This is 300 degrees, all the way around. So that lands right here at this ordered pair.
So, which quadrant is which? Is it like
1, 2, 3, 4.
Okay, that's what I thought.
So
I was making sure.
So isn't that silly though? Like, wouldn't you think we'd count 1, 2, 3, 4?
Yeah.
So we don't because trig won. Trig came first. So because we opened up our angles in this direction, we're opening into quadrant 1 and then 2 and then 3 and then 4.
Also, because 1 is positive.
They called dibs. Algebra came next.
What? Oh, it's good now?
Yeah.
You're recording.
Oh, okay, thanks. All right. So again, if I were to just make a little sketch, my 300-degree angle opens up and lands here in quadrant 4. And I'm approximating that. So I don't memorize my unit circle. I draw a sketch and approximate stuff because I know this is a friendly angle. Then I can envision short leg, long leg. Can you see it?
Yes.
So 1/2 and negative root 3 over 2. That's the ordered pair. So if you can imagine it, so then what's the cosine value? 1/2. So cosine takes the x coordinate.